Orbex has run out of money. Does that mean trouble for Europe's commercial rockets? China performs an important test with its moon capsule, Amazon gets permission to grow its Leo constellation by thousands of satellites, and VAST gets to send astronauts to the ISS. As always, we've got all that and more coming up this week in Spaceflight. China successfully conducted an in-flight abort test of its Mengzhou capsule this week. This was a significant test of the next-generation crew capsule, which is planned to carry Chinese astronauts to low Earth orbit and onto the moon. The uncrewed capsule was launched from the Wenchang Space Launch Center on February 11th atop a prototype booster for the single-core Changzheng 10A, which is still being developed. The full rocket is expected to make its debut later this year. As the booster headed towards the Kármán line at supersonic speed, the vehicle reached the point of maximum aerodynamic pressure, otherwise known as max Q. The capsule's abort motors pulled Mengzhou safely away, allowing it to slowly descend under parachute and make a soft splashdown offshore from the launch site on Hainan Island. In the past, we've seen similar in-flight abort tests conducted for NASA's Orion and SpaceX's Dragon capsules. It's a key part of achieving human rating for the vehicle, simulating an emergency where the crew needs to escape from the launcher during ascent. Completing this test is a major milestone for China's manned lunar exploration program and was its first maritime recovery of a return capsule. But this wasn't the only process being tested with this launch. The booster also demonstrated a controlled re-entry and a splashdown of its own. Once it passed the highest point in the booster's trajectory, it began an unpowered descent using 4 grid fins to guide it back to a designated landing zone. The booster is designed to be reusable and is powered by 5 YF-100K engines, which burn rocket-grade kerosene and liquid oxygen. 3 of these were reignited for an entry burn, and then again for a landing burn, reducing to just 1 engine for the controlled vertical splashdown. Now, while this first test landed the vehicle in the sea, future missions plan to catch the booster on the ship that was stationed nearby. The Linghongzhe, which translates to Pathfinder, is an autonomous rocket recovery platform around 144 meters long and 50 meters wide. This splashdown is said to have tested the ship's own systems to simulate catching the booster. In the future, it would do this using a net system with tensioned wires designed to catch the booster during its final descent. China plans to land astronauts on the lunar surface before the end of the decade. This test should now clear the Mengzhou, or Dream vessel, for an uncrewed demonstration flight later this year when it will dock to the Tiangong space station. With China completing such a massive milestone in its lunar program, we should also take a quick look at what's happening with the US's lunar program. In a surprising move, SpaceX appears to have shifted its focus away from Mars to the moon, where it now wants to build a, quote, self-growing city. This is pretty surprising, as the company has had its eye on Mars since the very beginning, and company officials have repeatedly referred to lunar missions as a distraction from those plans. Of course, NASA isn't ready to head off for the Red Planet just yet, so it makes some sense that SpaceX would realign its space exploration plans with those of its biggest customer. Not counting Starlink, of course. That doesn't mean that the company has trashed its Mars plans entirely, but it's certainly a change of pace. If you want to learn more about this pivot, Max discussed it and its effects on the Starship program in more detail on this week's Starship Update. Meanwhile, NASA is still working to get the SLS rocket for its Artemis II mission ready for launch. You're probably aware that the agency delayed the mission after hydrogen leaks plagued the wet dress rehearsal test in early February. Well, engineers have since replaced 2 seals in the areas where the leaks occurred. This involved detaching plates that connect the rocket to its ground infrastructure in the tail service mast umbilical, which houses the hydrogen feed lines used to fuel the core stage. NASA is now analyzing the removed seals and has planned some additional tests at its Stennis Space Center to obtain more data on how these plates behave. In addition to replacing the seals, the agency has also added 60 minutes of extra time to the countdown to allow for troubleshooting and changed the procedure for the next wet dress rehearsal so that closeout crews won't need to go to the launch pad during the test to close Orion's hatches. Hopefully, this will all help NASA to get SLS tested in time for the next launch attempt, which is now set for early March. Beyond Artemis II, the agency is also preparing to start testing for Artemis IV. This mission will introduce the SLS Block 1B, which has a new upper stage, the Boeing-built Exploration Upper Stage. NASA wants to test this stage at Stennis and has been readying the test stand with some upgrades, including a new cooling system capable of handling the energy produced by the stage's 4 RL-10 engines. The agency activated the cooling system in the last few days of January, spraying water all over the place as intended. The water helps to cool the parts of the test stand meant to direct the hot exhaust away from the rocket, and a flexible seal, cooled by water and gaseous nitrogen, will allow the engines to gimbal during the test. Artemis 4, the first mission to fly the exploration upper stage, is currently scheduled for December of 2028, but it seems very likely that that date will slip. But with continuous progress on lunar programs around the world, these moon missions seem to be getting closer and closer every week. Let's now check in with some of the companies in the race for the European Launcher Challenge, an initiative by the European Space Agency to support the development of low-cost launch vehicles. Now, unfortunately, it's not all positive this week, so let's start with the bad news first. The UK launch service provider Orbex is set to appoint administrators after attempts to explore a potential sale, merger, or fundraising have been unsuccessful. In other words, they ran out of money. You might remember from a few weeks ago that the exploration company was interested in buying Orbex, but that deal appears to have fallen through, and it now seems like it might be the end for Orbex. The company had planned to launch its 2-stage prime micro-launcher from UK's Saxavord launch site in the Shetland Islands. Orbex had already lined up several satellite customers for the vehicle, which was due to begin test flights later this year. The vehicle stands 19 meters tall and over 1.5 meters wide, comparable to Rocket Lab's Electron with a lower payload capacity. It's powered by a renewable biopropane fuel and liquid oxygen. This propellant stood to significantly reduce carbon emissions by around 90% compared to the kerosene-based RP-1, and Prime also featured a lightweight carbon fiber structure for additional efficiency. The news marks a setback for the UK's independent small launch ambitions, though Scottish company Skyrora is still progressing with its own plans to launch from the Saxavord launch site. This week, the company expressed interest in acquiring certain Orbex assets, including the Sutherland spaceport, for which Orbex secured a 50-year lease in November 2022. Though they did break ground at the site, 2 years later, Orbex paused construction indefinitely and pivoted focus to launching from Saxavord. Skyrora says that securing select assets is vital to preserving UK space capability, protecting national critical infrastructure, and ensuring that technology and IP development in the UK remains under UK ownership. Now, we'll have to see what the end of Orbex means for the European Launcher Challenge. Last November, we asked ESA Director General Josef Aschbacher about the program, and he seemed prepared for a change in the lineup.
What I want to achieve as DG of European Space Agency is to have these launchers that they are competitively available on the market. There may be less in the future. I'm sure that this number of 5 might be changing in the future. But what I want to have is to make sure that we help them, that they can develop a heavy lift launcher of the size of Ariane 6 in the years to come.
Fortunately, the program is very well funded, and there are 4 more players taking part: PLD Space, Maia Space, RFA, and Isar Aerospace.
I don't want to qualify one over the other or compare one with the other, whether one is better than the other. This is not fair, but also cannot yet be judged, because we have to see and to wait for their first flights.
So ESA wants to see rockets fly before judging them. Of course, we've already seen the first mission of Isar's Spectrum rocket, but when will the next European Launcher Challenge rocket fly? Well, we've got an update from Rocket Factory Augsburg this week, and it's also aiming for a maiden flight of its RFA-1 rocket from Saxavord in the second half of this year. The company secured its launch operator license in early 2025, the first for vertical orbital launches in the UK. The license allows it to launch up to 10 times per year. RFA has strong backing, including funding from the European Space Agency's European Launcher Challenge. The company has also built dedicated launch infrastructure for the RFA-1 at the site's launch pad Fredo. RFA reports that the pad is now completed, with the exception of the water tanks for the deluge system. The umbilical tower, which will support the rocket and provide it with propellant, now stands 52 meters high. Around 5 kilometers away, the Launch Control Center is also completed, hosting both the Mission Control and the Range Control Center. Elsewhere on the launch site, Saxavord now has a completed hangar for assembly, integration, and testing, plus a clean room for payload processing. All going well, RFA is positioned to achieve the UK's historic first vertical orbital launch later this year, and plans to begin some key tests on the pad in the coming weeks. We'll definitely be keeping a close eye on them. Now, of course, Germany's Isar Aerospace can already claim the first vertical orbital launch attempt from continental Europe when its Spectrum rocket launched from the Andøya spaceport in Norway last March. This brief maiden flight ended around 30 seconds after liftoff. Spectrum's second launch attempt has been delayed until mid to late March of this year, but if successful, the company could achieve the first orbital insertion by a private European launcher. You can be sure that NSF will be there to capture that moment, and if you don't want to miss out on this and other key launches, make sure to subscribe to our channel and set up notifications so that you don't miss anything. Now we'll take a look at some other stories across space, starting with VAST, which gets to send 4 astronauts to the International Space Station. You may remember from last week's episode that NASA had assigned the 5th private ISS visit to Axiom Space, but this week, the agency announced that the 6th mission will go to space station company VAST. The 14-day mission could launch as soon as summer of 2027. The company announced its bid for the mission in late 2024, and it wants to use the collaboration with NASA to gain experience operating space station missions, which will then feed into the missions of the company's own space station program. VAST is working on a small station called Haven 1, which in itself is designed to test technology and processes for the company's larger future space stations. Last month, we learned that VAST had pushed the launch of Haven 1 into the first quarter of next year, which means that the company might actually send up astronauts to Haven 1 before this newly announced mission to the ISS. But that's all assuming the current schedules hold, of course. So what rocket will the upcoming ISS visitors launch on? Well, when VAST announced its bid for the mission, it had already secured a contract with SpaceX to fly the mission on Crew Dragon. That makes sense, of course, as Haven 1 is designed around Dragon to the point where it actually relies on the capsule for a few crucial functions. It'll certainly be interesting to see how the Haven 1 missions compare to an ISS mission from the same company. NASA has suspended operations of its Neil Gehrels Swift Observatory as a result of orbital decline. Now that's usually terrible news for a spacecraft, but it might not be as bad this time around. So what's up with this observatory? The spacecraft launched in 2004 on a mission to study gamma ray bursts. It's outfitted with 3 telescopes to study these powerful explosions in, well, gamma rays, but also in X-ray and in visible and ultraviolet light. These intense signals are suspected to be released from dying stars as they go supernova, and Swift discovers about 100 of them each year. Originally, Swift's mission was planned to last only 2 years, but NASA just kept extending the mission, and it's been chugging along for over 21 years. Its orbit is now decaying rapidly, and normally that would mean the end for a spacecraft like this. But NASA has a bit of a trick up its sleeve to stretch Swift's lifespan even further. Last year, the agency awarded Arizona company Catalyst Space Technologies a contract to reboost Swift to a higher altitude and extend its mission once more. There's one problem, though. For the best chance of a successful reboost, the observatory's average altitude needs to exceed about 300 kilometers. It's now fallen below 400, so it's getting close to that point. To prevent the spacecraft from falling too low, NASA has now decided to temporarily suspend some science operations. Swift will continue detecting gamma ray bursts, but it will no longer study them with its other telescopes. This will allow NASA to adjust the spacecraft's orientation to minimize drag while it's awaiting its reboost, which is currently scheduled for this summer. Let's hope that they'll make that date, because this satellite needs a boost swiftly. Another launch pad making great progress towards operational readiness is Launch Complex 16 in Florida. Relativity Space has been busy advancing both the ground systems and launch facilities in parallel at the site, despite the chilly start to the year. The horizontal integration facility is looking nearly complete now, as sidings begin to be added to the booster processing section. The concrete pour for the launch mount has been completed, and structural steel installation is underway as the pad comes to life. Construction has also begun on the engineering support building and continues at pace around the site. Over at the NASA Stennis Space Center in Mississippi, engine acceptance testing has completed for the first stage Eon-R engines. Development testing of the vacuum-optimized Eon-V engine for the second stage continues, while additional infrastructure is being added to support future test campaigns. This includes vaporizers that convert the cryogenic liquid into a controlled gas flow. Meanwhile, at Long Beach in California, we can see the partially reusable Terran-R rocket really taking shape. Nicknamed the Wormhole, this massive site serves as both the company's headquarters and its main production hub, and was previously used to manufacture Boeing's C-17 cargo plane. The The latest video from Relativity shows progress across both stages. All cryogenic COPVs are now installed on the second stage, while the first stage tank has been moved into the integration stage now that welding has been completed. Relativity is still working towards a maiden launch in the second half of this year, and you can be sure that we'll keep a close eye out as it progresses ever nearer to that launch pad. Amazon has been given approval by the U.S. Federal Communications Commission to expand its Amazon LEO constellation to over 7,000 satellites. The FCC has granted permission to deploy an additional 4,500 satellites in 2 additional configurations. These will cover a second-generation equatorial system and a polar orbit between 590 and 650 kilometers in altitude. This would bring the total planned constellation, previously known as Project Kuiper, to roughly 7,700. This is a big regulatory win for Amazon and will push their ambitious low Earth orbit network towards current Starlink proportions. SpaceX now has over 9,000 Starlink satellites in orbit and crossed 10 million active customers this week. With the service almost doubling in customers annually, it already has FCC approval to grow to 15,000 satellites, with ambitions to more than double this number. And if you think that's a lot of satellites, another of Jeff Bezos' companies, Blue Origin, recently announced its TerraWave service. We covered this in more detail in a previous episode and in a Breaking Space Explainer, so make sure that you watch that video for more details. Amazon also announced its first 2 maritime reseller agreements this week. These partnerships are with MTN Satellite Communications and Dubai-based Elcom, both of whom already resell rival Starlink services. The deals will position the company as a direct challenger in the lucrative maritime SATCOM market, where demand for high-speed, low-latency internet has surged. The additional Amazon LEO satellites will support additional frequency bands, increased global coverage, and accommodate second-generation satellite designs. The approval requires that half of these new satellites must be launched by February 2032, and for all to be in operation 3 years after that. With this week's launch aboard an Ariane 6-4 rocket, the company now has 212 satellites in low Earth orbit. Additional launches are booked across Vulcan Centaur, New Glenn, Atlas V, Ariane 6, and yes, even Falcon 9 vehicles, with 10 more missions booked late last year. Let's just say there are many more launches for us fans of spaceflight to be looking forward to. The European Space Agency has signed contracts to kick off development of its next big asteroid mission. The Ramses mission will visit asteroid Apophis before it flies by Earth in 2029. Although we do know that this 375-meter asteroid won't hit Earth, it'll come closer than 32,000 kilometers, which is within the orbit of geostationary satellites. Passing so close to a planet wreaks havoc on the asteroid as it experiences intense gravitational forces, and ESA wants to take this rare opportunity to study exactly what happens during this close pass. But the clock is ticking to execute a mission like this. To reach the asteroid before its Earth encounter, the spacecraft has to be launched in spring of 2028, and that's a very quick timeline to build an entire spacecraft. Fortunately, ESA has a plan to make this happen. Ramses is based on ESA's Hera mission to visit binary asteroids Didymos and Dimorphos, where it'll arrive later this year. The Hera spacecraft was delivered on a strict schedule, and by building upon the spacecraft's architecture, the agency hopes to replicate that same success with Ramses. OHB Italia, which was also involved with Hera, will develop and build the Ramses spacecraft, and Italian company Tyvac International will provide one of the mission's 2 CubeSats. Both companies signed their contracts with ESA this week, so everything seems well on track to meet that ambitious but necessary launch date. This is your weekly space traffic report provided by NASASpaceflight. It was a busy week in spaceflight with launches from all around the world, starting off with the launch of a Chinese space plane on February 7th. Lifting off from the Zhochuan Satellite Launch Center, a Changzheng 2F carried the Changfu Sheyang Xi'an Hang Tianqi, or CSSHQ, into space. It's a reusable experimental spacecraft akin to Boeing's X-37B, which has been flying missions for the U.S. Air Force and later the Space Force since 2010, and is currently on its 8th flight across 2 vehicles. The Chinese space plane flew for the first time in 2020 and is now on its 4th mission, although we don't know whether it's been the same vehicle every time or not. Like the X-37B, CSSHQ's missions are very secretive, so we don't know what it plans to do on its flight. It'll likely conduct experiments or release some satellites like it did on all 3 of its earlier missions. We'll just have to wait and see. China launched its next mission on Thursday, February 12th, when a Zhelong 3 rocket lifted off from the Dongfang Hongtiangong launch platform to launch a Pakistani Earth observation satellite and 6 other spacecraft into sun-synchronous orbit. This was only the first of 4 flights that day, and the second lifted lifted off from Baikonur mere hours later. This was the first launch of Russia's Proton rocket in almost 3 years, which carried the 5th Electro-L weather satellite into a geostationary orbit. Just half an hour later, the United Launch Alliance's Vulcan rocket lifted off from Space Launch Complex 41 in Florida, carrying 2 satellites for the U.S. Space Force's Geosynchronous Space Situational Awareness Program. On the way up, the rocket unfortunately experienced an anomaly, or an observation, as ULA calls it, with one of its 4 solid rocket boosters. It appeared to have burned through its nozzle, which later threw some debris into the rocket's exhaust plume. Regardless, the rocket seems to have been able to deliver its satellites into their destination orbits, which the Space Force later confirmed. The issue bears resemblance to a similar anomaly that happened on Vulcan's second flight. The impact on the rocket's upcoming launches remains unclear at this time. Ryan made a video over on the Breaking Space channel analyzing the failure and what it might mean for future missions, so check it out, it's a good one. Later that day, a rocket lifted off from Europe's spaceport in French Guiana, lofting a batch of internet satellites for Amazon's Leo constellation. The mission marked several firsts, as it was the first to fly on Ariane 6's 4-booster variant, and the first to use the rocket's 20-meter-long fairing. The mission successfully delivered 32 Amazon Leo satellites into low Earth orbit. Of course, we also had more internet satellites launched throughout the week, as SpaceX launched 2 Starlink missions, both lifting off from Vandenberg Space Force Base in California. SpaceX wrapped up the week with its Crew 12 mission to the International Space Station on Friday. The crew of 4 consists of Commander Jessica Meir and pilot Jack Hathaway, both NASA astronauts, accompanied by mission specialists ESA astronaut Sophie Adano and Roscosmos cosmonaut Andrei Fedyaev. The capsule and its passengers are set to arrive at the orbital outpost on February 14th, with docking scheduled for 2015 UTC. This marked the 5th flight for Freedom and the 2nd for Falcon 9 booster B1101, which touched down successfully on the brand new landing zone LZ-40. SpaceX constructed this pad at the Slick 40 complex to replace LZ-1, which was decommissioned last year after the company's lease expired. Going into next week, SpaceX plans to launch 4 Starlink missions, 2 from California and 2 from Florida. Last week, Firefly announced that the launch window for the 7th flight of its Alpha rocket opens on February 18th, or early February 19th if you set your clocks to UTC. The mission will be the return to flight after the failure on Alpha's 6th flight in late April of last year. During that mission, the first stage disintegrated after stage separation, and the resulting explosion damaged the upper stage engine, preventing it from reaching orbit. Firefly plans to use this next flight, called Stairway to 7, to test technology for Alpha's Block 2 configuration, which will fly from Flight 8 onward. Hopefully, the unfortunate lessons learned paid off, and this one will perform without any issues. As always, some other launches may pop up in the schedule after we publish this episode, so we recommend that you check out nextspaceflight.com or download the app on your phone to stay up to date. And that's your weekly update of spaceflight news. I'm Alicia Siegel for NSF, and we'll see you all again next week to recap this week in spaceflight.